Hello, everyone. Welcome. So this is our August, almost September edition of the OpenLineage Meetup. And so today we have a few things on the agenda. So one, I'm going to talk about some of the progress of OpenLineage, where we are with OpenLineage support in Airflow, and some of the new evolution of the static lineage. And then we have several special guests, John Lukenoff, who's going to talk about Marquez and OpenLineage at Asana and how they use it. So I'm going to go fast, and he's the real star of the show tonight. It's more interesting talk. And, for small groups, or we just, the goal is to have a conversation. Feel free to interact, just chat over things. It's not meant to just like presentations. So that's it. So we can get started. So on the OpenLineage side, I'm going to do a quick introduction of what OpenLineage is and what the goal is. So we were talking earlier about OpenTelemetry, and OpenLineage is really like OpenTelemetry but for data, right? So telemetry, you have services and you have requests, and you can track metrics and traces and dependencies between services. In OpenLineage, you have data pipelines, jobs, and data sets, right? And the key difference is in OpenTelemetry, requests downstream are synchronously generated from the upstream request. So it's a tree, right? You have a first request upstream and it triggers downstream request and so on. Here's a tree. In OpenLineage, it's a bit inverted in the sense that when you're a data pipeline, you write your data set, and then some other data pipeline is going to be scheduled to some interval or in some way and consume from that data set and write to other data sets. So it's kind of polling usually more than triggering downstream transformation. And there's always this decoupling through data set of the upstream job and the downstream job. So as a producer of data, you're not necessarily aware of the downstream jobs you're going to trigger by your update. And so, but OpenLineage follows that same notion that we're going to instrument all those running pipelines, and that's the best time to get metadata, like how many rows were written, what was the version of the code, what was the schema of the dataset at the time it was reading from it or writing. So this is, like the goal of data observability. So the OpenLineage mission is to define an open standard for the collection of lineage metadata from pipeline as they are running, right? As opposed to a lot of lineage, I think we've seen so far was very static analysis, after the fact and so on. And so this is a bit of a different approach and looking at you. Welcome. Please sit down. You can sign up on the sheet over there if you want. Please help yourself on the table. Feel free to sit, and pizza's coming. And oh yeah, and by the way, we are recording this so that you're aware. Just the screen and the.
Where's this posted?
So I'm just recording it. So what we're going to do is post it on the OpenLineage YouTube channel. That's where we post all our monthly meetings, the Zoom online meetings that we have once a month. And so I think we'll just put it there. So before OpenLineage, you have a lot. So on this screen, I'm showing maybe like open source component as examples, but really that applies to proprietary commercial product as well. But there's a general idea where there's a lot of systems or projects or products that are trying to consume lineage, and they're all like reverse engineering various aspects, parsing SQL, like looking into the internal of those data pipelines to figure out lineage. And there's lots of duplication of work, and not only duplication of work, but it's also very brittle because it's reverse engineering things, and it depends on the internal. So whenever something changes, you have to do it again, right? It's a moving target. Lineage is not like this. So It's like constant work, it's brutal, it's lots of duplication, everybody needs it. So it's a perfect use case for let's agree on the format. And instead of everybody kind of talking to everyone and figuring out their API and N-square communication, we just kind of agree on the format. It's a lot simpler. Now the producers of Lineage can be responsible to adhere to the format and to the contract, and everybody can consume it. And so it can be a lot more stable, more reliable, and you're less broken by changes in something, or you're not depending on each other anymore. We can share the effort, we can make one for everyone, and that's a lot better. So that's a general idea of OpenLineage, right? There's before, it was a mess. After, it's a lot easier for everybody. So there's lots of incentive for people to join the community and the project. Right, so success so far. And so that, I'm not going to go into details of OpenLineage. You can find a lot more information on openlineage.io, but that's the general goal. And so the whole community we bootstrap by creating a lot of open source integration. And Marquez is the reference implementation of OpenLineage. You can use it to build your own things on top. And we're going to talk more about this afterwards. There's interesting early adopters who've been consuming OpenLineage or producing OpenLineage with Egeria, Microsoft Purview, which is the Microsoft Data Catalog governance tool. There's some Snowflake integration. Manta, it's a data lineage company. Atlan is a data catalog, so you can find details on the OpenLineage website on how they integrate with it. And also there have been others like Kibula is an ETL tool, Matillion is ETL tool, Soda is a data quality company is looking into it. Metaphor is also a data catalog that recently adopted OpenLineage.
A question. So yeah, Sandeep Bama here. So a question on the early adopters. Do you have timelines of when they will go in production?
So Egeria is an open source project. We just integrate with OpenLineage. Purview is in production. So you can find documentation on the Microsoft website on how to use OpenLineage and Spark, particularly how you send your Spark lineage to Purview. Snowflake, it's an experimental, it's a, they have a Snowflake Labs, GitHub repository, and there's a repo in there that provides a tool to translate from the access history, Snowflake has this access history feature to translate that to OpenLineage, but that's kind of, it's not, this one is more like, it's in their lab section. Manta, I think it's production when they can consume OpenLineage, and Atlan is also production. On the right, Metaphor, it's very recent. I think it's production ready, I'm not sure.
Has anyone,
the others are not.
Have people heard of Metaphor? They're sort of this social componency or democratization of data. So they came out of, one of the founders came out of LinkedIn, and he worked on Data Hub. So there's two projects. There's Acro Data, which is focused on data catalog, and then Metaphor, another startup that came out of that team. But they're focused more on annotating your data and kind of pinging people. Oh, by the way, it seems like this schema is out of date, but they've got a lot of funding. And we're going to be doing, I think we're working to do a joint blog with them on OpenLineage. So it's in the early discussions there.
Yeah, and I haven't listed AWS, but there's a great AWS blog post that explains how you deploy Marquez.
Some of my colleagues.
Oh yeah,
I'm not author, but yeah, I work with them.
Yes. So there, it's not an AWS feature, but it's explaining how to deploy Marquez in AWS and how to wire OpenLineage into it, and doing all of that in AWS.
And also, does that mean they are like working towards production?
Metaphor is the Kibula, Matillion, they talked about it. I'm just not fully aware of what's at. But they have things that are working. Kibula could produce OpenLineage. So I think in Kibula it's like an option you can turn on and produce OpenLineage.
And it's kind of tough because the teams reach out to you, you have a conversation, and they get excited, and then they go dark for a little bit, but behind the scenes are like actively working. So we can only give you the status of recent contribution data.
So we have relationship with some of those, but not all of those. And there are others who have things in the work we're not talking about. Like, people don't want to talk about it until it's ready, right? So those ones are things that have been talked about publicly on the website, or either in the monthly meeting or on the blog. There are also people who used it, but they're not always ready to talk about it.
What is outside in advices?
What's what?
In the Bootstrap integration, you have to.
Oh, so Bootstrap integrations. So actually, let me go to my next slide. So I'm just explaining how we bootstrap the whole OpenLineage ecosystem. So at the beginning, we met a lot of people to agree, okay, that makes sense. A lot of people had the same problem. Like, of course, we need a standard. I don't want to be reinventing the wheels all the time. So we kicked off the spec based on getting together a bunch of people from open source, based on our networks and agreeing on starting things. And we, I think Data King specifically, but contributing a lot of the integration. Some of those came out of the Marquez project. Like support for open source, you can do this from the outside, right? For Spark, for Airflow, for DBT, for Great Expectation. And there were also some using the APIs, like BigQuery as an API that returns lineage. Snowflake had the access history. So kind of bootstrapping the ecosystem, but then you want all the proprietary system to buy in as well, right? So that you cannot do from the outside. So that's where your lead adopters come in, like Microsoft has been a great partner. Nigeria is this other governance open source project that's used by banks quite a bit, and so more like native integration, like Menta and Atlan. They did all the work, right? And like, how do we consume OpenLineage? How do we produce OpenLineage? Because it's all proprietary to their system, right? And so that's where you get the inflection point, and the more people adopt it, the more there's value in the ecosystem. So there's a great incentive, right? Like every time someone joins, it makes the whole ecosystem more valuable, right? Which creates more incentives for more people to join and buy in the system and create this snowball effect. There's kind of like the picture here in there. So that's kind of what I'm trying to show with this, we bootstrap the ecosystem and then there's lots of adoption. Right, so that's all I have for the introduction to OpenLineage. I don't go too much into details, but please, there are a bunch of presentations we did online where that goes more in the details. But tonight I didn't want to spend too much time. So the other thing I wanted to give an update on is OpenLineage in Airflow. So one of the goals of OpenLineage is to be just a spec. Ideally, all OpenLineage is a bunch of JSON schemas. That's how OpenLineage events are described. That describe the metadata, and everybody codes against it, right? Whether it's producer's lineage or consumer lineage. And of course, to bootstrap the ecosystem, OpenLineage also contains a lot of integration to open source systems like Airflow and Spark and so on. But we just reached one of the big milestones, which is moving all the Airflow OpenLineage integration into Airflow itself. So now OpenLineage support is built in Airflow. Right, so it was, so Airflow is this AIP process, the Airflow improvement process, which is how you propose an improvement to Airflow. So the AIP 53, which is related to that, was accepted in February. I link here, like there's a whole presentation we made to the Airflow community to explain the rationale and why it makes sense. And I'm going to go through some of those slides, but like just to go quickly. And it's just been released, so Airflow 2.7 has built-in support for OpenLineage. Is the Apache Airflow providers OpenLineage providers. So when you install in your Airflow instance and you configure it, and it sends OpenLineage event to wherever you want, whether it's Astronomer or Purview or Atlan or whatever data catalog you want to use. And so now it's built in Airflow. So I'm going to talk a little bit why it's a huge deal. So before, with this mechanism of extractor, right? Like for each Airflow operator type, we had a corresponding extractor who would know how to introspect in the operator and extract the lineage. So, like when I say, oh, you reverse engineer and you depend on the internal thing, this is what I'm talking about, right? So, of course, the big downside of this is every time one of those operators changes, it breaks integration. So there's a game of catch up. There's a Airflow release, something gets broken, we fix it in OpenLineage, and then we keep catching up, and there's some ongoing work. Right, and so you build an extractor, it's for a given list of operator and knows how to introspect those in Airflow. Right, so that was before. And there was a bunch of extractors that were available, for all the SQL database, for Great Expectation, for some other things, and so on. And then things break because a lot of things are changed. It makes it complicated. If you have custom operators, it will also make things more complicated to add support for. So how do we fix it? Instead of having external extractors, each operator now is responsible for its own lineage, right? And that's something like actually John's team is using, and we had introduced slightly ahead of that, which is a new contract for operators to themselves expose their lineage. So instead of looking inside and extracting things, the operator has a new contract which just exposes what are my inputs and outputs and makes it explicit. So what we did, we moved all the extractor logic into the actual operators in the Airflow project. And now it's built in part of that. It's tested part of Airflow, right? It's part of the responsibility of the project. So whenever someone changes an operator, they also change the implementation of this contract and the unit test out together. And so there's never a release of Airflow that's going to break the contract anymore because it's part of the Airflow contract. So I'm talking ahead of my slides, right? No need to expose internal. We detect head. It's in the operator. It's part of the contract. And so before there was a lot of manual things. There was no standardization, so now it's all automatic. The same idea as OpenTelemetry, right? It's just you have the right things. It just exposes all the information you don't need to. And it's also from the operator maintainer, it's a lot simpler because you don't have this separate class that is in the separate project. You put everything in the same class. It's all encapsulated. You test it together. And it's really a lot easier to maintain. If you write custom operators, it's obvious how you add image support to it. You don't have to go and do a different API to do it. And from the maintainer perspective, yeah, most of the things needed for OpenLineage are already in Airflow. It reduces the bugs, it reduces the cross-project dependencies. It's all a lot easier. Right, so it's easier, and it's going to be a lot easier to add a lot more coverage in all the Airflow operators because now it's built in. Like the entire Airflow community can contribute. And if you're already a committer to that particular operator, it's really easy to contribute this as opposed to put it in a different project where you're not a committer. Right? And so there's more coverage coming, like XCOM datasets. Like sometimes people share Meetup from task to task through XCOM in Airflow if you're familiar with it. And some of the things like currently Python operators are a bit opaque, but that makes it a lot easier to add a hook listener mechanism in Airflow to get lineage through the Python operator as well, and make that easier.
Yeah, just to talk about that, I mean, since we have customers running or using our Astro product, we know what operators are being used and which ones don't have coverage. We do see a lot of Python operations, which makes sense because you have custom code. So if we could get down to the hook level, we could better provide lineage for customers that are heavy users of Python operators. So, anyways, that's going to be a huge for us, but also I think for the general community ecosystem.
So yeah, and in terms of what that means for OpenLineage, so the OpenLineage project still has an OpenLineage Airflow package, but now it's recommended to use it for versions of Airflow prior to 2.7. It's still going to be there. We'll probably fix bugs as well in there. But then from now on, all the features are going to be in the Airflow itself. And part of, so if you're beyond 2.7 that just got out like a couple of weeks ago, then you should use this one. And eventually, I think we'll deprecate the old package once a significant portion of the world has moved on to Airflow 2.7 feature. And ideally, we can manage to do this for other projects, right? Like Spark. It would be so much easier to just have lineage built in Spark. And then instead of, right now, we have a similar mechanism to extract lineage from Spark. Spark has this key execution listener, and you can implement. That's what OpenLineage does, and inspects a logical plan to extract lineage from the logical plan. And instead, that's just could be part of Spark, and have each logical operator just expose data source, expose the name of the dataset they're ready to run into. And that's a future. And then OpenLineage is just spec, and each project takes responsibility for exposing lineage from itself.
Any community member working on that Spark, getting OpenLineage integrated in Spark?
So we need to do the same thing. So what we did for Airflow, first you need buy-in from the community, right? Like, so we did this AIP process to say, hey, this is what we're planning to do. This is why it makes sense, and then the committers voted for it. So we need to do the same process with Spark, or like, people who are Spark committers are welcome to help with this. It's a decent amount of work. You can't just like open a PR, right? You need to make sure it makes sense for the community, right?
And the proposal will have a stronger case, now the rollout with Airflow. So as you put the proposal together, it's not just like randomly we want to add OpenLineage support to Spark. We can say Airflow adoption, and you can show the growth there and contributions. So you kind of need to build a case for a lot of this. And it did take a long time. I don't know. It's
yeah,
from start to finish.
I think we should not. It's not just a technical issue. It's like we should not underestimate the human getting to consensus aspect of things, right? So, but yeah, I think my opinion is will happen eventually, right? It's just like like more people can help, like moving. If we move mountains one people at a time. I guess I don't know if this is a good category for the thing. So yeah, so any more questions about this Airflow thing? That's it. Okay, so, and it's working the same as I know you're using the case of OpenLineage+. I think it's mostly the same contract. And so we can just work it. So the other thing I'll go quickly is static lineage. So as I was describing, OpenLineage was focusing on instrumenting running jobs, right? And the thing is, there's a lot of metadata or lineage adjacent metadata that is known outside of running jobs before they started running, or just about data sets and so on. So people in the community started pushing for like, hey, how do I express metadata outside of the running jobs, right? And so that's what the static lineage in OpenLineage is for. So, we initially OpenLineage focused on, okay, there's a job that's running, it's running from a dataset, running to the dataset, writing a red line. This is the version of the code that you can do this. And there's a start, there's the complete event, and capture this. And we collect a bunch of information, which was the schedule time, if it's a SQL query, what was the query ID, how many rows were written, what was the schema, the input at the time, right? Like a bunch of metadata like this. And so if we're looking at the data model, you have this run state update, and it identifies the job. The job is the recurring things that runs maybe daily or hourly. The run is that particular run for this job. And then there are input and output data sets, right? And in that information, so I colored here what is in here with the gradient is the dynamic metadata that is specific about this run. So you have the run facet, which are pieces of metadata about the run itself, right? Like what was the schedule time, different things like that. And they have the job facet, which are things that are more static. What's the version of the code? It doesn't change every run, right? And same thing on the data set. You have the data set facet, like for example, what's the schema? That doesn't change every run, it's more like static. And it's changed sometimes, but not every run. And then you have the input dataset facet, which is metadata that is specifically about the input for that run. For example, the same thing for the outputs, right? For example, on an output dataset facet, we will capture how many rows were written to this output in this particular run of the job, right? So the things that are ingredients here are more dynamic, and the things that are like plain or solid are more static metadata. So we figured actually we should take out all the static metadata and enable the user to send the static metadata outside of runs. Like for example, I just redeployed the job, it has not run yet, but this is the new version of it. I should be able to send an event that says, there's a job, this is the version of it. There's a data set. I looked at all the tables that exist in my data set, in my database. I should be able to say, those are all the tables that are in there. This is the scheme. Hey, welcome. Please join us. I'm just doing the introduction status, and then we get the actual interesting.
Hopefully the last one stuck downstairs. Hopefully the last one stuck downstairs.
Oh, you were stuck downstairs. Remember that we stopped waiting downstairs. Did you?
I just posted everywhere.
Sorry for that. Oh, did you? Someone opened the door for you?
That someone came up to from the basement to the lobby and opened the elevator door open. Once the door opened, I guess we can get it.
Nice. Sorry about that.
All right, keep an eye on the channel.
I didn't get any message there.
I saw a couple of DMs, like the organizer, and like.
Oh, it's in general. Okay. Because last time people posted on the Meetup, so I've been monitoring the Meetup messages. Anyway, welcome. Pizza just arrived. There's drinks. There's a sign-up sheet. I'm just 2 slides away to finish this part, and we can take a break, and then we do just. There's so the static, and so basically start creating new events. There's this notion of job event, which is the exact same thing as a run event minus the dynamic part. So you can say there's a job. It's just being if you know the inputs and outputs you can provide. Those are the data set I'm reading from. Those are the data set I'm writing to. If you don't know, it's okay. You can say, oh, this is the Git SHA for that version I just deployed if you want. So you can give static information about the job independently of running. And same thing, you can do a dataset event, which is just saying, I know about this dataset. This is its schema. This is its owner. You may have an owner for the dataset and capture all this information. So basically, those are the static lineage events that we added that kind of run the spec more. And so on this, the next step, yeah.
So those job and data set event probably going to happen only once. It's static, right?
Yeah, they could happen only once or only when you change something. Let's say you change the owner of a data set, then you send a new event. But like the run events, they happen at the time the job runs, right? Those ones, they're more like, oh, I just redeployed the job, or I just changed the owner of the data set, right? And I want to send this information. But you might be sending a single facet for the data set. Maybe you're just sending the owner, or it's been deleted. So you're just sending an event that says there's a deleted facet that says like this table doesn't exist anymore, or something. So this is fairly new. So we're still seeking feedback. It's been added to the spec so people can use it. Marquez doesn't implement it yet, but it's going to be in the works. We're looking for more feedback from the community. I think we wanted to enable people to use it before it's like fully implemented in Marquez. There's been some debate, should we wait until it's implemented in Marquez to release the new spec or not? And we decided to release it earlier. That lets other people in the community who do data catalog and also start using it faster than you get it, right? So that's a general idea.
Where are we on the airflow side of that committing static defense?
So airflow doesn't, like, so one thing I like to see, for example, is that airflow telling us when there's a new job being deployed, like so you have a new tag, it hasn't run yet, but it's there. Because sometimes the job not running is a problem, right? Like, so you need to know the job exists and it's not running. So if you capture only the runs, you don't. And the job has been removed is also important because then in Marquez, we can delete, you know, if you deleted a job right now in Marquez, since it only knows when it runs, it doesn't know the job has been deleted. So we'll be able, Marquez has a feature to delete those jobs manually, but then you'd want to automatically sync that from Airflow. So those are two examples of things that would be very useful.
Is there out of the box coverage for certain operators like min, median, max, standard deviation, or is it all based on custom operators?
So there's support for the Great Expectation operator. So Great Expectation is this Python library that lets you define data quality checks. And when you have, like, for example, if you do a data quality check on, there's some data quality check that also output distribution or like quartiles and distribution. And then we capture that. We save that in the metadata when we do this. So if you say there should be no more than 20 distinct values, Great Expectation is going to also output how many distinct values there are in there, and we're going to save that and pass that automatically. We're going to keep track whether the check has passed or not, and we're also going to keep track of the value that the check returns. So you can see if, oh, did we slowly creep to pass the threshold, or did it just suddenly went to big value, right? You can see this kind of history that's interesting. Some operators will give you automatically how many rows were written, which, you know, like performance data quality metric, like how many rows, which is very useful. You know, like, for example, if you use BigQuery, the API returns how many rows were written. If you use the Spark integration, it's going to return how many rows were written, and we save that in Facet. For things like Snowflake, we use the query parser to get the lineage, so we don't have this information, not in the operator itself. So, you know, it depends. When it's available, we try to extract as much metadata as we can, which can be, and keeping track of that over time can be very useful. Okay. Any more questions on that? Otherwise, I'm in between you and the pizza. Like, so maybe I should. Yeah. So we're going to take a break, eat pizza, and I will pause the recording. Welcome back. So now we're going to get to the next presenter, who was John Lukenoff from Asana. And I'm going to stop sharing so that you can start going.
Cool. Hey everyone, I'm John Lukenoff. I work at Asana.
John, you're not sharing. Just... There you
go. So Asana's just rolled out an MVP of the OpenLineage platform using Marquez. We use Amundsen as our data cataloging tool. So I'm going to give a quick demo with some anonymized data of our Amundsen integration and kind of how lineage from OpenLineage represents itself in Amundsen. Kind of starting from square one, Asana primarily uses Airflow for triggering pipelines. Our operators are almost exclusively custom operators. So we'll extend base operator and Python operator and provide our own mechanisms for querying databases and triggering Spark jobs from there. As that's the case, we can't really benefit from like the native operator integrations that we have. So what we've largely done with OpenLineage is implement these get OpenLineage facets on start and on complete methods. most of our operators boil down to like some base abstractions that we can add these to, fortunately, and get a lot of benefits from other operator types that are forked off of that. We are primarily relying pretty heavily on the OpenLineage SQL integration. OpenLineage SQL is like an experimental, I think we're still calling it experimental, feature of OpenLineage that, given like some SQL string, will give you the OpenLineage inputs and output data sets. So we really hook into our operators and just get like the SQL that they're executing, and then render the OpenLineage data sets from that and just return an event as is described like in this documentation. So we get a lot that way. And then we emit that to Marquez. And I think because there's some new folks here who aren't as familiar with the project, Marquez is like our endpoint and UI for emitting OpenLineage events to. This is not our Asana implementation, but it looks pretty similar to this. So you can see a list of your jobs, your data sets, and track events. Right now, we primarily use this for like debugging lineage. If things aren't working the way we expect, we can come in here and have a good UI for checking that we're getting the outputs that we expect. My GitPod is crashing, but
I think they cleaned it up after X number of stale minutes.
okay. Let me start that real quick in the background, and I'll go ahead and like move on to what a Munson looks like.
Also, it's awesome that you're using that GitHub.
Yeah, I've been using it a lot lately.
Yeah.
For anyone new to the project, GitPod is awesome for like just checking out Marquez. You just go into the repo, click that button. It'll spin up here over the next minute or so, and then you'll have implementation you can check out. So we send everything to Marquez. Marquez is great for like a really granular, complex lineage graph. We found that for like data scientists who are just interested in understanding what tables are feeding this data source, and going one level deeper than just the description of the table, Marquez is a little bit too much for them. It's a little too complex and tends to be a little more confusing and information overload than what they're looking for. So we enabled this integration with a Munson. Again, this is all anonymized data, but basically what you get in a Munson is when you feed in your lineage events from Marquez, you get these upstream and downstream columns. So those not familiar with the Munson, it's a data catalog. You search all your data resources. You can add descriptions and gotchas for your tables and tags. You can annotate with like column metadata, link dashboards, but it doesn't index processes and has a pretty, it has its own lineage capability, but it's pretty rough and difficult to work with. So Marquez saves us a lot of time in being able to get this level of lineage, which our data scientists and pipeline builders are very happy with, because this is like the simplest possible view you can get of lineage. A lot of times they just want to know where things are coming from in a very general sense. They don't necessarily care about the processes that are populating it or the intricacies of when the DAGs run and like what tasks are populating jobs. So you get your upstream tables, your downstream tables. I believe Amundsen also has a column lineage interface. You'll see this is only table level lineage. The other thing you get in Munson is a table level lineage graph. So you can see here, it's basically the same information represented as a graph. We can go quite a few levels upstream and downstream. This does get pretty complex depending on which data set you're looking at. But that's the general idea, is that it's purely table level, super simple, super readable. And we've gotten pretty good response from this implementation. We also really like that using the OpenLineage information, there are ways you can like link up which Airflow task is populating a data set. It's not implemented here, but you can click through to like, I'm not gonna click that link, but it's the source code and the schema for the table can all link up here using the OpenLineage metadata. Any questions?
Are you using the source code location facet?
Yeah.
Okay.
There are some, Amundsen isn't yet like purpose built for ingesting from OpenLineage. There are some kind of like somewhat hacky things we did to like make this work. We do this by querying the Marquez database, and Amundsen wants a really simple input of source table, target table. Like they really just want the two data points there. And that's what they build all of this like upstream and downstream of the lineage graph off of.
I have a question. Are you, I don't think we have a tag facet or label facet. Would that be something that you'd be able to then, because I see you have tier 1 and so forth, like would you be able to then use some of the facets, like a tag or label facet to annotate the?
You could, yeah. We use, Amundsen works by having these like data builder jobs. So the way we do it is we scrape our database and get all the DDLs from the database, and then augment that with YAMLs that people have written that have all the gotcha type or tags and owners and descriptions.
Okay, so you're sort of enriching it with a different data set.
Yeah, exactly. Okay. We think eventually it will be bidirectional, like we may want some of this data in Marquez if we plan to depend on it as more of the servicing more of the UI need for this. But this is basically like our MVP. Getting it to be represented in Amundsen was like the aha moment for our team, because people know Amundsen, they use it a lot. Seeing, especially like when I showed the Marquez demo to our teams, it was like some excitement, but this is the demo graph. And this looks really ingestible, but when you have like a real production, like as a lot of us who use Marquez know, a super massive graph gets a little bit hard to explore. So everyone was really excited about it, but at the same time, a little bit cautiously optimistic about whether that would be useful for day-to-day scenarios.
Yeah, this basic question, but so you're still feeding the information in lineage to market, right?
Right.
And then you're querying it periodically.
Correct. Yeah, like every day, on a daily basis, we run our data builder jobs that do other things. We just added one more data builder job to get lineage metadata from the Marquez value and feed it into Amundsen.
And like you pull everything, or like incrementally what is changed?
We refresh everything every day. Yeah. So this is like what ours basically looks like, but with a lot more nodes. And it's good. I mean, Marquez has worked really well for us for some troubleshooting use cases actually already. We had some incidents where we were missing data, and it helped us trace back what would be affected by that, and specifically like what jobs we needed to run backfills on. So even with the MVP and not having full coverage across our entire data ecosystem, we already saw great value in being able to do that, where previously a data scientist or data engineer would just be exploring someone else's code and trying to trace back logic through our code base.
So did you look at the graph in Marquez and kind of scroll through it?
Yeah.
Okay, but it was big, I assume it was wide.
Yes, it was wide, yeah. And having the feature to limit the depth helped. I wish we had had this full graph toggle. Cause that was like, this made it a lot easier. Even this can be a little confusing with a really large graph, but being able to filter out stuff you don't care about is nice.
So you remove full, we get only the upstream or only the downstream, right? That's what this does. This
Oh,
is a new
yeah.
feature.
I was supposed to present on this at the last. So without full, this is like originally what we've always done in Marquez. You see there are all these nodes that aren't part of the actual lineage path. Toggling full removes all of those nodes and just gives you the nodes that are along the vertical path.
Only the upstream and downstream,
Yeah.
and not things that are
Exactly.
related.
Mhm.
Makes sense. Yeah, that makes a lot of sense. Cool.
Yeah, so I actually am seeing how well received this very simple list of upstream and downstream was. I think it would be really nice to add a similar feature here.
I completely agree.
Yeah.
I think there should be different representations, because yeah, like the graph by itself maybe should be the last resort. If you really don't know what you're looking for, but maybe if you click on a job and you get the immediate upstream and downstream data sets.
Yeah.
Seems easy to add. Again, anyone here who's looking to contribute to the UI, those things like that just are no-brainers that would really help.
The API has all this information, right? So you can navigate the graphs. It's just a matter of adding.
In the UI, yeah.
So, go ahead. I have some questions just on internal adoption, but if you just have more to talk about.
Yeah, go for it.
So, right now, I'm assuming, are you targeting certain teams and saying, what is the feedback? And then working with them to then continue to expand the graph, so you're not just kind of saying it's ready for prime time. So you're trying to do this incrementally. So maybe where are you currently now? Where do you want to be? Where all this is, where else is this all going?
So we were talking about Asana has very disparate tool stack, and we have never enforced rules about everyone has to use X or Y tool to process data. As a result of that, we have a lot of different tools. That decisions help us scale and move with a lot of velocity. But now, as we're trying to add in all this observability, that's a challenge. We're really focused on getting a very basic level of coverage across all of those tools. And really, thanks to all the extractors available in the OpenLineage project, we're able to do that. And have some reference point for teams to build off of, and eventually hope that they will own the ongoing maintenance of ensuring accuracy of the lineage graph, maintenance as they change and update things. But I think we're still getting in the process of evangelizing it within Asana and getting data teams to see the value such that they will raise their hand and volunteer to maintain it themselves, which we are seeing. Any other questions? That was really all I had. Yeah, we're super excited about it. A lot of people have been relieved that we're doing this, and solves a lot of problems for us. So it's, yeah, an exciting thing to be rolling out.
So it's already in Amazon, or is it something you are going to push in the?
This is in Amundsen. The methodology of extracting from Marquez is still in our own code base, but we would like to add that it would probably go in the Amundsen project.
Yeah, so we do know Mark Rover. We've always, it's been a while since we talked about in the early stages of Amundsen working with Marquez. But now that you have pretty much a proof of concept that's working, might make sense to start those discussions again.
So Mark Rover is the lead for the Amundsen project. Yeah, I think it would make a lot of sense. We should talk to them, and if you want to do a PR on their slide.
Yeah. It's worth mentioning, there is an Amundsen, in Amundsen, there's an OpenLineage extractor, but the way you need to format the lineage events such that it works with that is a little bit tricky when you're using the basic Marquez OpenLineage setup. You basically need every event as like a line separated JSON. And you just pass that file to the extractor, which seems simple on the face of it, but it turns out to be pretty complex when you have everything being fed into your database already. It ends up being easier to just query the database. And
Yes, there's two ways, right? Like, because Amundsen has this notion of backend, lineage backend, where you can change the thing that stores the lineage. So they have implementation for graph databases and a few other things. And so here you're implementing the lineage backend. So you're using Marquez as a lineage backend that stores the lineage. The other way, which is the other way you were mentioning, is you use another lineage backend that's backed by some storage like a graph database, and then you ingest into it, which is the other things you're mentioning. That's how it works, right? It reads finds,
right.
and then it ingests into another lineage backend. I think this one makes more sense because then just Marquez as the source of the thing.
Yeah, I think Amundsen by default is backed by Neo4j, so it's graph centric. It makes a lot of sense once you feed the graph into it. It is a little clunky to like take this tabular data and that's representing a graph, transform it into a graph into Neo4j.
Is Marquez also GraphDB based on?
Marquez is backed by Postgres.
Yeah, it's just Postgres. You have to take like Postgres and move to GraphDB like in this.
Yeah.
In the builder.
Yeah. Amundsen's data builder functionality provides some abstractions for being able to write to Neo4j, such that you don't have to like implement all the nuts and bolts of it.
Could you show the version history tab on the previous view on Marquez?
Yeah, so that's the seed data from the demo Marquez, so it has only one version. But basically you see the evolution of the metadata over time. Okay, so if the schema changed, you can see when it changed, what it was before.
Yeah, and is there a limit to, I mean, will that track changes all the way back to the beginning, or is there a limit to the timelines on?
No,
The limit we've run into is how much you want to scale up your database. We run into like storage limitations. We have some DAGs and tasks that run every 10 minutes, and they're pretty extensive. So we found that in theory, I think the UI can support it, and I think eventually this paginates.
Yeah, this paginates. So you get a very long history of data set versions here if you wanted to scroll through them.
and there's not, it would be cool if if you let's say if you had 10 data sets and then there's different field numbers. I mean, we kind of just said, let's just add the field number. But imagine if you could click on 2 data set versions and see the change. A lot of it is going to be the schema, but it'd be cool if you could just have a diff view like that.
Yeah, by default, Marquez keeps everything, and you have to configure the retention job to delete beyond a certain time. Because then the problem is, if you have lots of stuff, it goes to.
Yeah. No, I could see that being really helpful for like the GDPR example you mentioned, where you want to be able to kind of track changes over a given time period. And I think you said those jobs are run daily, and you could ultimately have an eye on that going back all the way back to the beginning of the sets of changing, right?
Yeah, absolutely. Yeah, we're rolling out. This is kind of a foundation for some data governance and control initiatives that we're rolling out. So we're at the early stage of starting to see how we can use this metadata for that.
for your data governance initiatives, did any use case came where you don't want to show all the upstream and downstream with the some? What access?
I'm not sure. I think, I'm not the one who's owning a project, but, yeah, I think there are scenarios where we don't actually would want to expose, metadata to certain users. Like our employee data, you want to be a little bit careful with. But yeah, that might be an interesting use case in Marquez. I know something we've been talking about is off in Marquez and
Yeah.
how to implement like RBOC. And so that could be a nice.
I think we just need to do it.
Yeah.
We've been talking about it for a while. I mean, it was kind of okay if internally you just had, you hit some URL and then you have like auth picked up. If you had to be on the VPN or something like that, but at this point, there's discussions around some users want API key off. So Shiro is what I've been suggesting and recommending, and it would be a good framework that you can just add in your auth component, and I think we should just do it. So I don't know what the forcing function is. I just know the community wants it. It's just for us, we have other things to prioritize. But there's an open issue, and I would be happy to accept the proposal.
To help someone who wants to do it.
Yeah.
What we do for auth right now with Marquez is we proxy ingress through OAuth2 proxy.
Pretty much,
And
yeah.
federate with
What
Okta.
people have been doing.
That's the standard, but
Yeah.
you don't have roles in that. I mean, yeah, you'd want to have more role based if you're an admin. You might want to see certain namespaces versus others. There's a lot you can do there. I think that's a gap as well.
There are some projects that will pick up like OIDC headers, and they don't roll the auth themselves, but they assume if you layer on your own OIDC implementation that you can still define the role-based privileges through their own spec.
Okay.
Like, we do that with Argo CD or like our Kubernetes clusters.
And with the Munson, you just have users log in, they create an account, and or is it just?
I think a Munson is actually that way too,
Okay.
where we have it fronted with like a OAuth proxy. Yeah. Like you'll see this is our Munson and it picks up like my user info.
Got it.
And then I think there are some role-based controls over editing. I'm not sure how simple or hard that is to do. State of John's projects. So yeah, let's open Lineage and Marquez and Asana.
Amazing. Good.
Have a good night.